Namaste. My name is Anuradha Awasthi, as I'm working as a CSIR Senior Research Fellow in CSIR National Environmental Engineering Research Institute located in Nagpur, Maharashtra, India. So the topic of my presentation is solid-based water purification system for household wastewater treatment. As you can begin with the presentation, you can see here. Yeah, so basically if we can talk about the water, so what we can say, it's about water is a big global problem. How we are in India, we are facing lots of issues and scarcity of water as based on the data available by collected and reported by WHO at a worldwide and global level. And in our Prime Minister Modi call for such water conservation mission, that is the means of reuse and recycling of wastewater which is generated, and by which we can at least at some extent we can reduce the impact which is caused by the water scarcity. So here I have put some data. There is some 780 billion people lack of basic drinking water, as you all know. So if we talk about the sustainable development goal, there is a agenda 6 which reported that clean accessible water for all, which is essential and it is really required for the human being and the living organism which is living on earth. So what we can, if we begin with the water scarcity situations, here I put some global reports. We all know that UNICEF and the big organization basically working on the, and they are time to time reporting and basically working on the water scarcity situation, water, and they are just approaching us, they are just reporting us that there is a lots of scarcity of water. So as everyone is suggesting there is scarcity of water, there is issues related to the waters. So what are the basic approach that we can take as a challenge to treat a water, and that treatment can be at some extent that can be usable for layman and it can be available for pilot scale too. So here I put some global reports reported by UN and some UNICEF and a big organization that 3.2 billion people live in agriculture areas with high to very water shortage. As you can see here, I've reported some data. So if we talk upon the global issues, there is a lots of issues that is related to the water. Yeah, so if we talk upon the India, water scarcity status is India. Here I put some pictures on the city located in India, in Mumbai. It's a big metropolitan city. There is a lots of issue in a daily needs. People are struggling for their daily needs water. Even they are not having sufficient water for their household uses also. So in the Niti Aayog, it's a reporting that think tank. What we can say is, if we are thinking about the treatment of water, if we are thinking about the conserving the water, there is a lots of need to stop consuming consuming. What we can say, we can reduce the consumption also. By that way, we can also reduce the scarcity level, and we can approach at least some extent there we can be reach a good goal that we will use the water in a sustainable way, and that water will be present for future generation also. So some of the major metropolitan city in India, that is Delhi, Bangalore, Chennai, Mumbai and Hyderabad, as reported by the Niti Aayog, will run out groundwater by 2025. As in India, it's a very agriculture country and we are mostly dependent upon the agriculture dependent groundwater. So most of the people are affecting water scarcity situation in India right now. So these are the recent cases. I have put the images here. As you can see, Jal Jeevan Mission organized by Ministry of Water. So what we can say, they are just assuming, this is the hypothetical way that we are assuming that a single drop can play a major role. If we are saving a single drop of water, that can also be I think we can say make a significant impact on the conservation of water. So Jal Shakti Mission launched a framework for water monitoring, quality testing. So we are having lots of water in our country. We are having lots of water. Some reserve source also there. Sea water is available there, but the technology cost which is required to treat that water at some extent level that can be meet the permissible limits prescribed by the regulatory authorities. For that way we need some good technology, and by that way Jal Shakti Mission and the Ministry of Water is properly working for the treatment of all those things. So if we can say, basically we are working in, our group is working on the solar distillation. Solar distillation is nothing, is a distillation process. If it's a simple operators which is used for the treatment of water with the help of solar energy. The impurity settles down and the treated water, what we can say, it's a vapor which is collected in the treated can. As you can see in this image, I have put these simple images that most of the people, layman, doesn't know about the basic mechanism behind this. But what we can say, the basic sense, they are using a basic sense to treat their contaminated water, salty water, high TDS water for their potable and daily needed. So you can say a man is putting a single plastic bottle in this what we can inclined roof, and they are treating it. The hypothesis behind this is that all the bacteria and the impurity will settle down, and the treated water will come as a vaporized water, and that water will be used for different purpose. So as in India, here is a lots of solar energy potential. Natural availability around 300 to 330 sunny days, about 5,000 trillion kilowatts per year is yes. So here we are. So daily solar radiation is around 4 to 5 kilowatts per meter square. It's if we calculate, it's equivalent to 600 gigawatts. So the simple operators which is used for the treatment of contaminated water is solar steel, and this solar steel basically work on the principle of water cycle. Another major thing what we can say is we can use an advanced material for the rejuvenation of the basic and conventional solar distillation unit that can be used for different intended purposes. Use of novel material, basically on the carbon-based material, combination of different nanocomposites. It can rejuvenate the conventional technology at some extent, and that can be available for the treatment of contaminated water. So if I talk about the two things, that we have chosen photothermal material. They have a high stability, lightweight and low cost, and that can be easily better material for the rejuvenation of solar distillation process. And by that way, we can use these material as a coated material in the simple conventional system also, and we can use at these material and a nano suspension form also. So in my next slides, I'll present how I have chosen these material for the application for solar distillation application. Some of the major studies I have pasted here to describe. As you can see, passive solar distillation unit can be modified without use of any electricity additional support. Can be modified use of nanomaterials for high production costs. Some of the recent study I have reported here. As you can say, the design modification, engineering concept of solar distillation modification will be the best thing that can be used for different purpose, and that units can be used for the treatment of different kind of waters. So as I have said, I have chosen the photothermal materials. So for the photothermal material, I have chosen carbon family members. One is CNP, carbon nanoparticles, and another one is graphene oxide. As you can see, there is a hefty spectra of carbon nanoparticle and graphene oxide. To measure surface functionality are hydrophobic, which may be the reason for the aqueous immiscibility of CNP in water, and geopresence of mode hydroxyl group. Here you can see the peaks are designed here. Different peaks, hydroxyl groups are present, carbon and hydrogen groups are present. So these features are reporting the CNP with the method we use for the preparation of CNP is prepared a hydrophobic CNP, and another one is geo as a what we can say hydrophilic material. So for the application, we did this scanning electron microscopy test to understand the surface morphology. So as you can see, SEM report, this is the carbon nanoparticle SEM image, and the these are nodules grain type of carbon material. which is having 30 to 55 nanometer size, and graphene is a seed-like material. Some macroscopic fluorodepressant layered are found, and therefore the presence of flags in this geomaterial were fully oxidized, and these materials form as a hydrophilic graphene oxide. So what we are in our application for the solar distillation rejuvenation, we used CNP as a coated material on SS sheet and geo as a nano suspension for solar distillation application. Here you can see I have taken a small sheet of SS stainless steel, and I coated this carbon nanomaterial on this sheet, and I put this sheet in the water to check its coating stability along with the thermal performance. So this is the result of thermal profiling of coated sheet in controlled environmental condition. As you can see, the temperature enhancement in a conventional coated sheet, in the sheet which is coated with the carbon material, evaporated more water, 15 ml, as compared to the conventional distilled water. And here is the environmental condition result also reporting the same. As you can see, 30 ml is rest water and 20 ml is evaporated, the initial concentration of 50 ml. Here in the bank system, that is distilled water, only 10 ml was evaporated. Here you can say the temperature increase with a carbon coated sheet compared with the conventional system is 7 degrees higher as compared with the conventional. System efficiency in terms of water evaporation was improved by 15% using carbon coated sheet as compared with the conventional system. So here we have prepared the nano suspension of graphene oxide. As I already told, graphene oxide was prepared as a hydrophilic material. For the nano suspension, we use an ultrasonicator. We take 100 mg of graphene oxide and mix with the 100 ml of distilled water, ultrasonicate for 15 minutes, and transfer these in reagent. It was a sustainable and stable nano suspension. I have done the DLS and zeta potential studies to understand the basic phenomena and the characteristic of this geo nano suspension. After preparing, what I have done, I have the thermal profiling of geo nano suspension. As you can see, geo nano suspension is evaporated more water as compared to the CNP and blank system. What I have concluded, the temperature of geo nano suspension increased by 3 degrees as compared with the CNP nano suspension. Nano suspension of geo showed higher water evaporation compared to the CNP. And here is the UV visible spectroscopy result also reported that there is a no leaching has been found after the coating of the material, and nano suspension when is used for the evaporation process. What I have concluded with this study, that if we use a conventional system and we can rejuvenate these conventional system with the use of carbon nanomaterial, this system will available as an advanced material, advanced distillation system that will be run by the solar energy only. There is no need of any external electricity and other external supports to run these system. And these are kind of household wastewater treatment system. We can use a different water sample, as basically I'm working on the RO result treatment. So here I haven't put the data because I have plenty of data and the time limit was there. So I have just put the basic concept in which I am working. And this technology is also giving a best benefit regarding to the zero CO2 emission feature of solar distillation towards water treatment. So if we see a other concept of this development of this household treatment system, this major societal benefit which is generated by doing these type of experiments are decentralized solar distillation unit will be developed, and that can be providing a water in an emergency situation also. Rejuvenation of distillation process by the use of non-toxic material, and it will be a simply operated cost-effective water treatment technology for emergency services. So these are some of my objective here in the last March 2022, I have been awarded with the first Best Oral Presentation Award in an international conference. And this was my favorite, what we can say, memorable moment when I was selected for the OU International Water Conference. I was physically present there in 2019, which were organized by OU Water Center. And again, I have been selected. I am very happy to share with you that was a great experience when I was sharing my research experience with the vast what we can say audience, and I gained a lot regarding the what we can say in the research concept, along with the dealing with the people, so many things and so memorable moments I'm having. So these are some significant achievements that I have been delivered a talk on the tech process, innovation, development, and technology additional level in engineering college in India, and also be a part of Kalpana Youth Foundation, situated in the Mumbai on World Water Day. So finally, I just acknowledge to the directors, CSIR NEERI Nagpur, India, and my PhD supervisors, Dr. Sadhna Rayalu and Dr. Kavita Gandhi, and CSIR HRDC, as I'm working as a CSIR fellow for the financial support. And finally, I really acknowledge the support of University of Oklahoma and OU Water sponsor to giving me this opportunity to interact with you all and to present my work over here. These are some publications I have published my work, and thank you lastly, but I hope I will definitely present live when will be the time of my presentation. It's quite in morning, early morning is around as per the Indian timing, it's around 2 a.m. in the early morning. I will definitely present for the question answer round, and hope my idea will definitely enlighten you. And if any questions is there, if I will not present the live session, if any question is there, any queries there, please do let me know. Do mail me. I will definitely answer the things. Thank you so much. Thank you so much all for patience listening. Thank you.